All right. Well, welcome everybody. We wanted to get a little, maybe you can hear the background music there, but wanted to give you some insights on what we're going to do with thermal imaging and how it can apply for you and your business. Um, we were having fun with some background images. Unfortunately, I didn't get my video. I did comb my hair this morning, so I'm doing a mime impression right now. Try and make me flinch. All right, guys. So one of the goals here today is helping you understand how you can expand your business. If you're currently doing commercial business right now, it's an opportunity to expand that. For those who are not familiar with my company and myself, I'll explain that a little bit. But one of the things with United Infrared and what we do is mostly ancillary services and helping people understand how to increase revenues by adding these ancillary services. So let's go through a little bit of the agenda today. We've got an introduction to the session. We're going to go through some theory. You can see it doesn't take much. There's only a few minutes in each of these because of the fact that it's that easy. We're going to go through some current inspection methods. We're going to talk about how thermal imaging helps in the identification of electrical problems, some safety issues. We're going to go through some case studies and safety, and then obviously showing how it's been used in the detection of electrical faults. And then why home inspectors are great candidates for this type of work. And then, of course, just helping you understand that why these additional services are going to make sense. And then we're going to leave some time for some Q&A. As Miranda mentioned, and Brenda mentioned that we're going to go through and try and help you guys. So you can put in your best questions, and we'll try and get through as many as we can at the end here. And if I get through this, I understand we've got a lot of people on today, which is awesome. Love it. Thank you for joining me. Now, for those who don't know, I'm on Pacific time zone, so we started bright and early. In fact, when I left this morning, the sun wasn't even up yet. So, all right. So a little bit about myself. I am a level 3 infrared thermographer. We'll talk about that in the presentation and what does that actually mean. I am a code certified building inspector. I actually went to school 32 years ago with the intention of being a city or county inspector. I'm going to tell you, there's a lot of people that will tell you in life, you need college, you need all this. And I think there's probably a lot of people, very successful home inspectors, you probably don't even have a degree. I'm one of them. Never did complete a degree. I went straight into college with the intention of what I wanted in life. I was a C student in high school. I didn't like it. When I started taking code certification classes, we're talking at 18 years of age. I gave away my age, by the way, with that. When I started taking code certifications, I finished my agenda with a academic honor. So I got straight A's throughout the 2.5 years it took me to complete the curriculum. And so maybe I found my niche and what I wanted. I have been a home inspector for over 25 years now, many inspections performed. I do have a multi-inspector firm here in Southern California, and for those who've been in this business now for, let's say, some time, and you experienced that fun in 2007, 8, 9, I saw the economy change in 2005, and I made an investment into thermal imaging early. In fact, 2004, my business was flat. 2005, I watched a decline, a slight decline in my business, and I went and spent 20 grand that year in thermal imaging and trained 3 of my guys, and I've never looked back. And then, of course, as I explained, I started a few years later. Believe it or not, I started, in fact, I spent 20 grand within 9 months. I had paid back my investment on infrared work that I was doing. And within years, I realized the business was much bigger than me. And I started a company called United Infrared in 2007, 2008. And we quickly became the largest servicing company in the world. Currently, actually, about 45 U.S. states and 9 countries. We have about 350 thermographers that have gone through training and gotten certified through us, and are doing this service daily. So So kind of to give you a little intro, we did develop one of our products, which is called Electric IR, and we hired probably one of the most knowledgeable guys in the industry to assist us with this, and his name is Dr. Bob Matting. He is been doing this since the early 1970s. You can see a picture. Now, one of the key things to know about thermography is this equipment that you see on the left is pretty much how it was done. This was funded by the government. You know, they needed you know, they found there was a technology that can see things that our own eyes can't. You had to pour liquid nitrogen in this machine to make it operate. It was like 3 or 4 cases of material, and you had to put it on a roller cart. And today, you know, the one that's on the right, that's actually a model that they don't even make anymore. They've gotten smaller, better, and what you would spend in 6 figures on the left is now can be spent in, you know, sometimes in above $5,000, you can get a semi-decent infrared camera. So um, Bob is still working with us today. He is retired. He used to work with FLIR Systems, and he retired. He was their technical training for the Infrared Training Center. He pretty much started that for them, and he retired years ago. But he has taken on a position with us in our technical directorship. All right, for some that didn't be able to see all the video that went across, anyways, you probably got glitches in parts, but you probably heard the sound, and probably just for that alone, I mean, if you're a strong person in you know, just movies and stuff, for some reason this is one movie that most guys aren't forgetting. You know, it was back from 1987, but it was honestly some of the worst thermal imaging. It was, you know, very basic. The technology wasn't, you know, what it is today. And we're going to go into that more and why that makes a difference and why what we're doing, you know, as well. Um, so, you know, why do this? What is the purpose and why do we see this? It's just basically, you know, the main thing to understand when it comes to, you know, thermal imaging and why it's beneficial for a business is because, you know, safety and dollars are the bottom line. If these companies can't be in production, look what happened to our supply chain right now. I mean, try and go buy a bicycle. You go to your Walmart even, and they just have like 2 bikes or something. The supply chain got knocked down because of this whole fun COVID thing that we're going through. And at the end, it's like, hey, one little part stops the production. I recently, one of my printers for my inspection company took a dump, and I had to go get a new one. And I'm very limited on what I can get out there. And so, you know, that's what you need to understand is, you know, let's imagine the electrical, which is the lifeblood of these businesses. You know, you put a COVID type of situation, you know, let's say COVID's not there, but the electrical system is the disease, and if it fails, it shuts that whole business down. And so that's why this is very relevant, and I'm going to go through some of the guidelines and standards why this is so important and why actually this is not a difficult sale for you to incorporate. So a little history, first of all. The thermal imaging, it pretty much all began in 1964. It's the same year the space probe went to Mars, the first lung transplant. Ford Mustang introduced for the first time. How many of you guys got one of those? You're probably still holding on to it. And of course, that was the first commercially available infrared camera. Now, none of us were thinking about this. In fact, as I showed you in the earlier slide, most of us were introduced to thermal imaging through Predator. You know, we got excited for that one thing, and it's like, it's never left my mind. Honestly, when I made that business decision, you know, to get into thermal imaging, it was because actually one of my inspectors advised me that he could no longer do a third inspection every day. You know, we do like 8, noon, and 3:30 when our daylight is there. Right now, obviously, that's going to be changing. But but he advised me he couldn't do a late appointment. I said, "What do you mean?" Well, he had 7 kids and he needed to make more money, so he was doing infrared. He told me he took a job with this electrical outfit doing infrared work at Marriott hotels. I was blown away, and that was you know, that actually came to me in 1999. That's when he first told me this, and I wrote a business plan right away. But for anybody who's on this webinar that was doing inspections in 1999, you were busy. I mean, we literally were like 7 days out on inspections, and so there was really not an opportunity for me at that point, and that's what took me till that 2004 when I started seeing that change in business. So but I'll tell you, when I first looked into it, the quote in 1999 was 75,000. So if you remember, I said I paid 20. So between 99 and 2005, the price went down by literally a third, and so or a quarter, three quarters down, and so this is just the sign of what things are. And you look today and you're seeing infrared cameras start at around $200. And so this is kind of the economies of scale and how that happens. But this is why this opportunity is really now. And here's the main thing to know about this. Since 1964 and still today, electrical infrared testing was the first application. It is still the largest application of thermography testing going on right now. More businesses do this, and I'm going to explain why as we come into this here. So a couple things to know: that everything above absolute zero can be seen with an infrared camera. And so to give you an idea, my absolute zero is minus 459 degrees. And so although there's, most infrared cameras that you see on the market are going to see maybe a -5 to 250 or 700 degrees. I have a camera that sees 2,800 degrees, and you might say, what the hell's 2,800 degrees? I actually have a client. I have 3 of their facilities. I work in the Western United States, in fact, in Montana and Utah and California for this particular client. And I have one piece of equipment that is in the 1,500 degrees. It is glowing when I'm looking at it, and it is a critical asset that, and this is not electrical, but it's a device that's in the manufacturing industrial, and I have to inspect this particular device. So, yes, you're going to see these things that sometimes can be up at that high of a temperature, and sometimes there's going to be low temperature. So we're just showing you an example of how you can see ice cubes and kind of just the difference in temperature with that thermal camera. So one of the key things to know is that as you guys look at this slide right here, you can see the image on the left, and you can see clearly that, this is something we can communicate. When we have pain, we will communicate it. We'll cry like a baby sometimes, ow, it hurts. But see, the thing is that when it comes to electrical, it doesn't show itself. So I want you to kind of look at the picture at the right and tell me, do you really see something that could be wrong there? I'm going to give you a hint. It's where that orange dot is. All right. And I'll bring a picture up. But the key thing to know is before electrical and mechanical components burn up, they heat up. And those spots are not visible to the human eye. So although we can feel pain when it occurs to us, electrically, you're not going to feel it. You might feel it in a utility bill because you have energy loss when you have loose or bad connections. But this is where an infrared camera comes in. So I'm going to pop that picture up, and now you can see the looks of when that occurs. So when you have a problem, how easily it's seen. Now, for guys who need a little help in life, this thing makes you look like a genius. All of a sudden you found it. You're like, dude, I just turned on my infrared camera and I saw it. No, take the credit. Yeah, I found it, So what's starting off, an average guy, electrician, or anybody else is just going to see that connection. They're not going to see the problem. They don't know it. Now, I had a brand new home I did 2 days ago, and it was over a $2,000 home inspection because they hired me for everything, like sewer inspections. They hired me for infrared of the building envelope, and I'm going through this brand new home, and I had a complete burnt wire, in this sub panel. And those are things that you can easily see. But long before that happened, it gave a connection like this. And that's why the infrared camera is a very beneficial in fact, for those who do home inspections, you'll find that the 2 main areas that you're going to be able to see and use thermal cameras on is on the electrical and also with moisture. So for this reason, organizations like National Fire Protection Association have established guidelines on maintenance. And so for those, I want you guys to think to yourselves. You can write it down on paper. Maybe we'll make this an interactive quiz. I don't see necessarily a chat log, but if you guys, you don't have to punch anything in, just kind of think to yourself. But does anybody know what NFPA 70A is? So right here, I'm talking about 70B, but I want you to think about, do you know what 70A is? 70A is actually the electrical code, all right? 70B is another book. It's called Maintenance and Safe Practices for Electrical Systems, and it's actually, sorry, 11.17.5, not 21.17. It's 11.17.5, suggests that every commercial industrial building should have an IR survey at least once a year. Why is this important to know? Well, I'm going to tell you who doesn't know right now, is a lot of the insurance carriers don't necessarily know this right now, and they're picking this up. And the reason why I say this is because I have almost every week I get a call from a company saying, hey, I gotta get a do you guys do infrared scans? And yeah, of course. And then we'll find, well, we have to get a scan done before the end of the year. Is that something you can help us with? Of course. And come to find out, they got a letter from their insurance carrier. In fact, I have one in fact, I am, just to give you guys an idea, as I said, I own a home inspection company and I do home inspections regularly throughout this week. All next week, I have 5 days of commercial electrical infrared that I'm doing in Arizona. And so, and for those who don't know, I'm out of the San Diego area. So, enough that if a company's paying me to go to Arizona, in fact, not only that, they're paying me my drive time, travel time, fees, breakfast, lunch, and dinner every day, and more money than you can imagine to do these types of surveys. And so, but this company I've got booked for the first week in November, they literally, same thing, had just got this notice. Well, the reason why they got the notice is because they have a factory in New York where some of their electrical switchgear blew up. And so they had an electrical condition, and now the insurance carrier is mandating every one of their facilities get the IR survey done. And so, boom, that's what happens. And now carriers like that become aware of this standard, and NFPA 70B, that establishes that they need to get that done. All right, so here's the thing, is that can you afford not to do it? So insurance statistics show that nearly 70% of equipment failures are caused by human error and improper electrical connections or loosening of parts. When you kind of show up and see an extension cord, yes, that's an orange Home Depot extension cord holding some of your main switch, there's a problem. There's something wrong here. They should not be doing this. I'm going to tell you, I had a major airport that I did the regular switchgear work on for 5 years, and I showed up in equipment just like this, and on top of this equipment was a series of tarps. They had a roof leak that was pouring water into the switchgear, and so they installed all these tarps to capture the water and move it down to a trash can. It was awesome, so awesome. Did not want to be in that room, as you can imagine, but there was no rain at that time. But you can imagine kind of the things that people will do sometimes. And it's just, they've got to keep their business going, and these are decisions they make. Unfortunately, they can cause big problems and burn down facilities. And imagine if we have a problem on one of these cabinets, it usually carries itself over if a fire occurs. And so it takes down a facility. And that's why NFPA 70B was established with that guideline, just showing that maintenance and safe practices for electrical systems. And we're going to find as the years come, and that's why I tell you right now, you saw that, hey, the infrared camera was, 75,000. I buy it for 20, 15 years ago. And now that as far as electrical, if you're going to be doing switchgear testing and commercial, you're going to probably be spending close to 10 grand on a camera. But, there's a different way of looking at things. You can look at it like, hey, I'm spending or I'm investing. So these are things you need to know. An investment, the difference between, for those who don't understand what I just said there, the difference between spending and investing are what? Right? What is it? The difference is investment should yield a return. Spending is a vacation, maybe you're spending money, although the return is some rest and relaxation, which we'd all like to do. We can't really travel, right? All fun. That's why we're all sitting here on this webinar right now. All right. So the question is, can you afford not to? Again, it can show the problem before the failure occurs. So if we can do preventative maintenance, predictive maintenance, we can predict the problems before they occur, then you can do that repair. You can do this repair, like let's say in the evening or when the factory's down, or schedule a shutdown if they're a 24-hour facility. That's the goal. This breaker right here, to give you guys an idea, is like 5 grand. So these are starting somewhere around $1,000. It depends on the size, but some breakers are $5,000, $10,000. And so if this goes right now, a lot of times this can be a relationship of a bad connection, and sometimes it's just tightening it up. So all right, so it's not just that $5,000 or $1,000 of that breaker. What it is it's the loss of production. Imagine how many people are working in that factory that can no longer do that work. So that's the thing, is that if they are shut down because the electrical goes down, now you're paying for all these employees. So look at what COVID did to businesses. When it shut it down, a lot of people couldn't work. They had to lay off people. Obviously, this is an extensive waste of our economy right now, but it affected the entire supply chain of everything. So, and even though these statistics were 18, 19 years ago that you're reading, it's no different today. It's not the cost of the equipment, but the production downtime that's going to be in the hundreds of thousands or millions of dollars. So, all right, so from a return on investment perspective, infrared programs have proven that on average, for every $1 spent on electrical inspections, there's a $4 return on investment. So when you can take these statistics that were shown, and by the way, these are done, Maintenance Technology magazine is a big magazine that's utilized across the board, and a lot of these, companies, the facilities engineers read these, and these are the kind of statistics that they need to know. And this is no different today. In fact, if anything, the infrared service might have gotten a little bit cheaper. I can tell you, I haven't gotten cheaper. My average day, my minimum daily rate is $1,600 a day for electrical switchgear testing. That's my minimum. In fact, next week I'm out at $2,000, a day by the time everything's considered. And so, there's some pretty good money. If I gave you kind of a thoughts when it comes to this stuff, I mean, it's not my favorite infrared work is doing moisture detection, because I have no idea what I'm going to find till I get there. But this is the work that is consistent, and it comes back every year because of NFPA standards that establish that. I have one client that spends $25,000 a year with me. Every year, I've been working with them for 12 years now, and it's showing that it's pretty much a lifetime contract for me because we've had very big success. In fact, this company is a very large company. They have about 218 facilities in the United States, and I'm only doing California, but I started their entire program now that they've gone nationally with. And so I have 18 of their facilities in California. All right, so, you see this picture, and what do you think the expected downtime of this location is? All right, I want you to understand kind of what you're looking at. This is a data center, all right? And I want you to look at, you see these computer server racks. So you look at one rack. So look at that forward row. One rack is what, 2.5 feet wide and 7, 8 feet tall, all right? I want you to imagine to yourself, what do you think the cost of one rack is? Just one of those. Within that rack are about 10 servers. All right. So that's like, keep it about the size of your PC. You know, you got about 10 of those. How much do you think the value of that one rack is? All right. The answer, $1 million. So you can imagine like a facility like Google or any of those data centers, hundreds of millions of dollars. I work in facilities like this. In fact, one of my big clients is doing these types of facilities. I have one of them that's probably about, it's probably worth $250 million. There's easily the small data centers, they'll have, $20 million easily. And a data center, the downtime is literally has to be 0.0001. They never shut down. If they're a utility or if they're an information provider, people are searching, gathering that information, connecting to these servers all the time. And so they cannot be down. That's why it's important to test their electrical. And I'm going to tell you, I had one of these facilities in Phoenix that I did at a data center that was connected. They ran all the technology for the airport. And if for anybody who's ever been to Sky Harbor, it's a pretty huge airport. And if that data center went down, one of the main connections that was driving what's called a rectifier, and these are all terms you'll learn. One of the goals with this presentation is to help you understand you guys are leaving money on the table if you're doing commercial, or it might inspire you to spend money and invest in a business that might yield a return. So I'm kind of giving you some of the understandings of it with this presentation. That's obviously not going to teach you everything you need to know how to do it. That just takes time. But this one particular connection fed what's called a rectifier. And a rectifier is basically involved in the process of converting DC to AC to power the equipment, or AC to DC. And so what happened was they start off in main switchgear with what's called an ATS, you have a main breaker, you have an automatic transfer switch, so that if power ever gets interrupted from the utility provider, the ATS will switch over to a generator, which usually is just seconds, split seconds to change. The problem is that the data center was fed through a series of batteries, which is another backup. So if there's a failure in that, but most data centers, the battery life is about 4 hours. And unfortunately, the breaker that I found fed the battery bank. So if power went down, then the battery life was instantly done. So, or instantly not being powered, and you'd have about 4 hours of life. So that's about how long they have to fix something when it goes down in a data center. And most of them do have a battery backup. So that's why it's very important, and they have backup after backup. But when one of the major things was found, I found it literally caused an immediate havoc with engineers on the phone. The repair was completed within an hour on this system. So once we found it, because they couldn't risk that getting worse. So as I said, failure is not an option with most operations. Maintenance is the answer. And really, maintenance is defined as the act of maintaining or the state of being maintained. When business goes down, a lot of guys make decisions on, hey, we're going to cut budgets. And what are the budgets that usually get cut? They cut their marketing and they cut their maintenance. The two things that are just like critical, like to grow this business, we got to market it, we got to make exposure to it. And to keep this business going, we have to maintain our equipment. And, we know as home inspectors that our job exists because people don't maintain. What percentage of jobs do you go into and you literally have the filters are dirty? on the furnace. I mean, they're not maintaining it. The best example that I tell people, especially a lot of the youth and they're buying their first houses, you guys were taught to change the oil in your car. Why? Some of them don't necessarily understand, but it's really funny because I taught all this to my son, but he just didn't listen. This is just some of these millennials or something, didn't want to listen. And of course, he blew his engine up one day, and he had to learn the hard way. It cost him 4 grand to replace the engine in the car, and I made him pay it. And he learned. And the funny thing today is he works at an oil change place. He's like an assistant manager, and he's got a great story to tell people. So you maintain something so you can get your life expectancy out of it. If you fail to maintain it, the likelihood of that failure is a lot higher. And as I said, it's not necessarily just the cost of that equipment, it's the cost of that downtime and how it affects everything else downstream in the system. So a couple things to know about thermography and when it's done. It's done during normal business hours. You're not going in, even on a home, you can't do electrical testing when there's no load. In fact, I have a course that I train home inspectors. I've trained like 3,500 home inspectors on how to use thermography that have gone, these are ones that have gone through my course. And I emphasize the fact that when you do your electrical testing, you've got to power up the oven, the air conditioners. You got to run all your 220 circuits basically and turn on the lights in the house. Now, when you look at it, the lights, they're actually only about 20% of your entire load on the house. In fact, your HVAC is often 30 to 50%. And so, you want to make sure that, you get a load on the system. And that's the same thing in a factory or a business, is that they have to have the equipment running for you to be able to identify where problems may be. And so when you do find problems, honestly, and I'll show you some pictures as we go through this, but 90% of the problems are typically due to a loose connection. And why does that happen? Imagine expansion contraction. As you heat something up, and then it cools down, heat it up, cool it down, heat it up, cool it down. Those connections are expanding, contracting, and it ends up loosening up connections. When you look at it, just think of a residential panel. Well, commercial panels are like double that, and there's hundreds of connections. And for someone to go in there and tighten down with a screwdriver is going to be very tedious. We can go in there with an infrared camera and see exactly the circuit that's got the failure. And if you do have something that's not related to a bad connection, and I'll show you examples on how to identify that, by the way. You've got to do an amperage reading. So once I know, if I see an infrared picture and then I know the size of the circuit and the load, I can tell you what's wrong with it. And that's all experience-based, just being able to read that thermal image. All right, so I told you in the beginning we were going to talk about certifications and what's important. Many of you guys have probably gone through some class. Maybe you've gone through my class or you've gone through Monroe's class. I mean, all of these are great for when it comes to the home inspection aspect. InterNACHI has the infrared certified program, and so all of those programs are great when it comes to home inspection. But when you're starting to look into commercial applications, you're going to need to be looking seriously into what you have to have as a background, and that's where the certifications will be important. And so I'm going to kind of explain to you just the difference on those level 1, 2, and 3. Level 1, I'm gonna dumb it down as easy as for you guys as you can. So level 1 certification, and each one of these is 32 hours of training to complete that. You can do it online. InterNACHI has a relationship with Infraspection. Jim Sefferin's a friend of mine. I know him very well, and he's the director, and he can walk you through a lot of the same things I'm telling you, but then he can help you in getting to that certification level. Level 1 is really understanding what the word emissivity is. You know how to say it. you know how to spell it, and what it means when you're taking an infrared image. You have to understand also, you know, transreflectivity, also known as T-reflect. You have to know ambient conditions and how they impact the image. So level one is really knowing how to take a proper image and how to identify a problem. All right. Level two means that you know how to take a picture, which is what you got in level one, but there's some more advanced calculations needed, specifically when it comes to electrical. And so level two is really not just knowing how to turn on the camera and take a picture, but it is knowing how to turn on the camera, take a picture, and now actually write a report, which is the analysis aspect of the inspection. So, and then, of course, you've got one more level, which is a level three. There's actually another level after that. But level three means you know how to tell somebody how to turn on a camera, take a picture, and write a report. So these are usually instructors. We've probably got about 10% of our thermographers in United Infrared that have achieved level three. Worldwide, I would say it's probably in the single digits as far as what percentage of guys are level three out there that against guys who've gotten level one. I would say that it's in the single digits, low percentages, you know, 2 to 5% of guys are actually achieve level three. And it's really that's a guy who's basically an instructor. You can also establish guidelines for companies on how to, let's say, their procedures, like you guys need to do this every 6 months. I have one facility that I go to every quarter. So in fact, they have 3 locations, and I have to go to each one of their facilities every quarter to inspect and go through with thermal imaging. And so that was established by their maintenance program on a criteria on these facilities. And they're actually located throughout the United States. And I've got 3 of the facilities that I do for them and have been doing for about 6, 7 years now. And again, that'll be like a lifelong, because these facilities are in the millions of dollars, and if one of these facilities goes down, it such shuts down a supply chain. You know, so that's the key thing. And so they take the maintenance is nothing, because believe me, they generate, you know, so much money on these things. The cost of the maintenance is nothing, and they found that it keeps the facility running. Um, so the key thing to know that if you're going to be doing electrical thermography, you're going to be looking at level 2 thermography certification as a minimum. And the reason why I tell you this is because this is what your competition is going to be doing, is to you know, to be completing this, you're going to end up competing with guys that have good equipment. They've spent $10,000, $20,000 on their infrared camera. They've got the certifications, and they're doing this on a regular basis. So it's just something to keep in mind. And although there's no global requirement needed other than an IR camera and a passion for making money, many companies that level 2 certification, especially government organizations. So here was a criteria that was in one of my contracts, that actually stated that we had to have 5 years of experience as a thermographer and a level 2 or higher, and you had to maintain your certification. And so, you know, that's where things like partnering up with somebody sometimes might be necessary. Like, we as a company, I've had guys that have called me and have had criterias like this, but the good news is that we're able to meet those requirements in our company. We have people all over the US. So, you know, even when guys get a job requirement and they're brand new in the industry, they won't lose the job, because they'll still get paid, because we can run the contract through our company and then maintain their requirements. So those are things that are you know, you've got to make sure you, when you do get these jobs, reading the fine print and not turning it down simply because of that, but you know, utilizing resources that you might have. So here's the thing to know. I mean, we now have pocket infrared cameras that are giving a 320 by 240 resolution. There's recently a new change, a new price war that's going to be happening right now. We just saw for the first time two manufacturers have introduced a 640 by 480 resolution camera, which is considered HD kind of in the infrared world, although HD is now going to be going to the 1 megapixel infrared. You can think of our digital cameras that are in the 20 megapixel range. You know, the infrared has been in this 320 by 240. When I got in the business, 320 by 240 was the cat's meow. That was it. And we couldn't afford a 640 camera. You know, I spent $35,000 in my second year in thermal imaging. I spent 35 grand buying a 320 by 240. My first camera that I told you I spent 20 grand on, that was a 160 by 120. I love the camera. It made me a lot of money, but I saw the opportunity going to that next level. It was called a P65 for any thermography buffs out there. And some guys still love that camera. They think it was the greatest, but it did have a great picture. But now we've got a 640 by 480 camera, and there's two manufacturers, and I'm guarantee you there'll be a third and fourth and fifth that have launched in the $10,000 price range, which is amazing. And it'll give you some great opportunity. But the minimum in this industry is that 320 by 240. And so it's going to give you a picture like you see here. Just keep in mind that you're never going to show up on work, selling for $1,500 a day with a pocket infrared camera that, even though it has a 320 by 240. I recently, in fact, yesterday, one of my associates sent me a report from a stadium that the electrical infrared was done at, and I was blown away because the company told him, "Oh, we had it done 4 years ago," and he was telling me, he said, "Well, check this out." And of course, he knew all the requirements that the NFPA standard is that it needs to be done annually. 4 years ago was not sufficient. And on top of that, the guy took 89 pages of infrared pictures, but he only had the infrared picture and he didn't put any definition of what he was looking at. He didn't say the panel ID, the location. He didn't even put spots on the hot areas and use a criteria or do amperage readings, all which are necessary to do a proper survey. So the images you see on the right, if that was all I had in the report, this guy only had the infrared picture. So you didn't even know what you were looking at, what that breaker was, where it went to in a stadium. So just keep in mind that if you want to be serious and you want to advance your business into commercial electrical, you're going to have to invest in the business. And, when I tell guys they see these, let's just say anything below like the 6-7 grand range is going to be a lower, not acceptable. This guy had a camera in the 200, 220 by 160 resolution because he was using a standard template produced by the manufacturer, and I saw the camera model number, and the camera model number is a discontinued model of low resolution. It was an electrician who did the job. And the thing is that electricians probably really good at what they do, but have you think about anything in your life that you do once a year? You have to retrain yourself every time. And so it absolutely showed in his report. I can tell an amateur when I see one. It doesn't take much for me to identify when someone doesn't know what they're doing. So you don't want to be that guy who doesn't know what you're doing. And that's why, going through this course is going to help you understand kind of what you need to do that. And so this is kind of some examples of just some imagery levels, and these cameras, most all of these are discontinued. None of these models are current today, but that wasn't the purpose of this slide. It was really showing you where resolution and what you see. Now, no matter what, most customers don't ask you what kind of infrared camera you have. They ask you, can you do an infrared survey? And in all the cases of all the IR cameras, they're going to show the fault. In fact, that's what you see here is pretty much the same picture through all these resolutions. And what is the difference between them? Well, it's how clear it is. There's pixel, there's the spatial resolution, which is how many pixels it's got, the thermal sensitivity, which is how clear the image is. So look at the image on the left and look at a low resolution, low amount of points of measurement, and look at the image on the right, and you can see where how it's so much more defined and clear the more pixels that you have. And although we can see the faults on all of them, the accuracy is where this comes down to. And so that's why you're not going to show up with low resolution. You're going to show up with something in the resolution on the far right two images. And that's the kind of images that you're going to show. So you're seeing missing insulation in one on the bottom image and electrical on the top right, or top of each of those. And so some of the things to be aware about, I don't know if you're ever familiar with in commercial, but sometimes you'll see a label that'll say arc flash rating. And there are ratings that literally say there is no material safe in this world that you can open up this equipment. This thing's a bomb, you know. It basically says no PPE exists that you can wear that would be safe to open this up. And as I told you, infrared is done live, hot. It is hot work. And so sometimes it involves a specialty contractor. When we get clients that that have a panel that cannot be opened because the risk factor is too high, we have opportunity to sell them additional devices. Keep in mind, guys, this isn't a home inspection. You know, this is commercial work. It's a totally different field. This is where you can utilize devices like an IR window. And what that does is now you don't have to remove the cover on that equipment, and you can use an infrared camera to look through that device to see the components. And they have different types of IR windows on the market. Give you a general idea, what do they cost? It's about $100 an inch. So if it's a 3-inch window, then it's $300. A 4-inch window is $400, and pretty much all the manufacturers, Fluke, FLIR, make them. There's other company, Iris is another one that makes them. In fact, now they have a clear polymer so you can visually see through it. That's an opaque window. They're a little bit cheaper, but most of them have gone to the polymer now that you can visually see through. So you can kind of shine a flashlight and visually see it as well, which is nice. So there are opportunities, but these are things that you'll run into, and you need to make sure you know how to, walk the walk, talk the talk. And so basically, you might see sometimes on electrical switchgear where they put a window in. Those windows that are there are viewing ports, but infrared does not transmit through glass or plastic. You have to use specialized material, and that typically is a crystal or a polymer, depending on what kind of window it is. So I'm just giving you an example. This is a university here located in San Diego area that we were doing helping them with the IR windows. And we're basically showing where their switchgear is. We're going to put in 1 or 2 windows in this panel, and they use what's called a Greenlee, which is a press. And so they'll take this metal cover off during a maintenance window, and then they will press a hole into that metal and then install this window. Now, some of these companies can manufacture custom windows, so where those current viewing windows are, we can replace those, but those are in the thousands of dollars. So sometimes they'll just spend the $300 or $400. Will be easier for them than to spend the thousands to have customized windows put in that place. But we've had clients do it. Those are opportunities. So just these are examples of some high voltage cabinets where usually that arc flash rating is high. These, they simply turn them and open them, and then we'll look inside there with the cameras. So depending on the client, I've had electricians that refuse to open up some of this equipment, and then I've got guys that do it on a daily basis. So just so you know, most all the hazard exists when they open the cabinet door. So it's just a tip for safety is you'll usually find me, the first thing I do when I show up on electrical is I'm assessing the level of that electrician. I can see his competence and I watch. And when I get guys that I'm just not sure of, I leave the room until he's got all the gear open. Um, if I know the guy knows what he's doing, I'm usually hanging out and, rapping with the guy, and trying not to distract him, of course, but they do this regularly. And so it's never, different than what we do on an inspection where we open up equipment. I never open up equipment on electrical, on commercial. There's always an electrician, many times two, that are there to open and close the equipment for me. So I'm a picture taker. I'm a photographer, and I'm paid, just to give you an idea, I am paid double what the electrician makes, and I'm mostly standing waiting. I've got a lot of waiting time while they're opening and closing gear, and because they can't go into a room, open it up, and then leave it open. They got to finish it up right there. It's got to be, so you'll get a safety officer that comes through. So why is this important to know? Because insurance companies are requiring IR surveys of electrical and mechanical systems for their insured. In fact, I don't know if you guys, you can answer the questions to yourself. If you got somebody next to you, say yes. How many of you guys have a life insurance policy, right? So to get that life insurance, what did you have to do? You had to do something, right? You had to get your blood sucked out of you. Why is the insurance company who's providing that life insurance want to see your blood? They're assessing your risk. They ask you a question: do you smoke? Right? Or now it's, have you had COVID? They're all scared. Um, so it's the insurance companies need to see how much of a risk you are to be able to provide that insurance. I have $1 million of life insurance on me. I don't know if any of you guys have $1 million, but it's really fun because they made me go through a couple of medical tests, um, you know, uh, to before they would insure me. Um, and so, you can see my mugshot. I'm healthy as can be. My hair went gray. I don't know what the hell happened there. Well, it's been that way for a long time. You guys, some of the guys probably don't even have any hair now, right? Okay. So they were assessing the risk. Well, the same thing on an insurance carrier. Why do they want to offer insurance to someone without knowing the risk? So that's why they're using NFPA 70B 1117.5, because they're saying, hey, look, yeah, we want to offer you insurance, but we need to know that how safe you are. So they require them to get these surveys. And if they find faults, so when I do a survey, if I find faults, there are established guidelines on how long they have to get that fixed. All right. And they want to make sure they're fixed or they'll cancel them. I had a client in San Francisco area that needed an emergency service. By the way, a little tip, we always get the question, how much do I charge for this? And the answer is as much as you can get. You guys will never forget. So when I knew that this guy was in pain, I don't publish my prices out there because my price is different. It's based on a client. I have a roof survey for a government that requires a scan of a roof, and I've got that scheduled for the 25th of this month. I got a $3,500 check. It's going to take me an hour now. Granted, I've got a 5-hour drive each way to get to this client, but it's a $3,500 job. I don't publish my prices because I assess their level. This guy on the roof cannot get paid until I sign it off. And that was a requirement. You got to have a thermographer come in. Well, they don't do that. So that's why I get paid. But believe me, we're talking in the hundreds of thousands of dollars. $3,500 was chump change for them. They want to get paid. So electrical surveys are going to be a necessity. And we're right now, I can guarantee you, every week when I get a call that says a company who's never done it before and all of a sudden they're required, you can imagine the smile on my face. There's more work than my 350 guys can do. I'm going to tell you, there is a ton of work out there. It takes a little time to get it because you have to be patient for these insurance carriers to go at it. And we're working on it. We're in contact. The biggest carriers already do it, but there's more that don't. Sometimes they have a valuation like the company has to be more than $10 million for them to require it. So some of the smaller ones don't do it, but I'm going to tell you, if their risk is tied to the blood, the electrical system, it costs the carrier nothing. In fact, it's a pure benefit. And what is that insurance company's job? To increase profits. So they know their risk purpose is to reduce risk and increase profits. And that's probably the same philosophy of you, right? You want to increase risk. No, you want to decrease risk and you want to increase profits. So this is now kind of leads into how you react with your business. Do you do currently infrared, let's say even on a home inspection? Well, if you're doing infrared on a home inspection, are you increasing your risk or reducing your risk? Well, I look at it like you're increasing your risk. And the reason why is you're taking on a product that is beyond the scope of a home inspection. You have brought in a tool that's technically exhaustive that you're not required to do. Now, you made the decision as marketing, but I'm going to tell you, I've never done thermography on a home inspection for nothing. I charge for it. And so, I added $500 to my home inspection the other day just to do the building envelope, which took me 30 minutes, 40 minutes. It was a 7,500 square foot house, but it only took me 40 minutes to pull my camera out. But believe me, that $500, the return on investment's huge. So, but if I pull that out and give it away for nothing, I've increased my risk because there may be other things that I've taken on, like I missed something. So you want to make sure that you take the same philosophy as the insurance carriers. You want to reduce your risk and increase your profits. And so making more money on your inspection, we will exchange risk for reward. So CNA is one of the big carriers, and they do it thermography on pretty much most of their buildings. They're one of the ones that, like, if it has a 10 or $20 million valuation, they'll do it or require it on those facilities. And anybody underneath that, sometimes they give you benefits if you do have this, but they talk about the single largest cause of dollar loss in a business, and more than 30% of all fire losses is talks about, that the electrical is the cause of those fires. 30% of all fire losses are caused by electrical failure. And so why is that important with us? Because infrared thermographic testing can prevent the loss. And so you guys, this is open information. Just look up CNA infrared testing, and you'll pull up tons of data from this carrier that's just shown over the years of how this has made a difference. This is how they increase their profits, by requiring this of customers. And so because we've talked and shown you that you cannot see the physical heat without the infrared camera, that the risk for that company is there. You reduce the risk by requiring them to do it. And in effect, it increases the profit of the carrier. So, you can see how, hey, they can give you a 10% discount if you have this done because you just reduce their risk. Their risk is huge. Why are all these auto insurance companies right now giving you rebate premium? Well, they want to be the good guy. That's why. But the reality is, people for many months weren't driving. They're home. So that reduced their risk. COVID's made them millions. So they said, hey, I could give back a few bucks. And we're making more money because the amount of accidents got reduced because there's less people on the road. But then when that risk increases, like we're seeing now, we're back to seeing some traffic here in California. It was awesome for months when I could drive to Los Angeles in a straight shot in the morning. Now it's, starting to get back to that long haul of having to look at the car next to you for, pick his nose or whatever he's doing. So anyway, so just keep in mind. So here's what it really comes down to is surveys are really fast. They're cost effective. It's non-destructive technology. It causes no disruption of service. So they don't have to shut it down to do it. And this is an example. This client required us to be suited up. Just so you know, some of the rules that have changed in thermography is that if you're beyond the arc flash zone, which is typically about 6 feet back, you don't have to have any of this gear on. The gear is required for the electrician who is opening and closing it. And as I said, the risk is on this equipment when they open it, not necessarily when it's open like that and I can go over there and look at it. the risk is low unless you started hearing buzzing when you know got near it. In that case, you can stand back. So you know these are transformers that you see on the each end of these cabinets, and then this is your main switchgear room. This which is what you would be looking at here. Um, and usually they'll open up the top or bottom of each one of these cabinets, and once that's clear, it literally takes me 2 seconds to look at it. If I have a problem, then it takes me a couple of minutes because I have to document the location, the cabinet ID, the equipment room, and then what we saw, and then if there's any load readings, then we'll get that at that time. And I'm not touching anything, by the way. I'm just the picture taker. The electrician will be taking all the load readings that I need. He's going to stick his hands in there, not me. All right, so here's some technical tips that you guys need to know. Problems is what we're looking for. They're also called thermal anomalies. We're going to be comparing. For anybody who just remembers the old Sesame Street, one of these things doesn't look like the other, you know, so that is really what you're doing. You're looking at this picture and you're saying, all right, we've got a couple of capacitor banks here, and some of these don't look the same. Why is that? So this is where your camera is doing the work. It makes you look like a genius. You document the problems where they are, and then you providing that information to the client. And at that point, they're going to have their high voltage electrician doing the repair. Sometimes they have to shut down to fix this. Sometimes they're working on it hot. That's why those guys get paid the big bucks. So, you know, once you find a problem, then you really have to determine how bad is it. Well, there is criteria tables that are out there. We use a guideline called EPRI. There's an NFPA guideline. It's in 70B. It tells you certain temperature requirements. We'll talk about that. And once you do that, and once you know somewhat of a load or something, we can make a decision just by looking at these pictures what's going on. And don't assume because you don't understand this picture right now that you can't do this work. It's not that complicated. Once you, as in anything else, you can think back to your first home inspection. It was hard. My first home inspection, you know, was a condo. It took me 5 years. That same condo today takes me an hour. You know, so most of the time you're just going, wow, that's a cool picture. Wow, we got an explosion about to happen, and you're sitting there. And when you get going on this, you're literally taking the picture and already at the next, you know, system. So, um, you know, the key really is as you look at this photo, you don't realize it's changing in front of your eyes. And when we first started that photo, the photo was starting off where it wasn't showing anything. It wasn't in tune. And then all of a sudden, you know, we get when we tune that image, we can see the fault on that tap connection there. So you know, that's really tuning is going to be a critical part of this, and knowing how to tune and adjust to your environment is going to be key. Just a little tip, I don't care if you have a $200 infrared camera, just make sure if you're looking up in the sky that the sun is not going to be in your direct view. It's a good way to burn up your camera. That camera receives energy, and I don't think you want to pump tens of thousands of degrees into that camera because you're going to burn your detector up. So just a little tip right there. You also need to know that the environment does affect the what you are looking at. So if you get literally like a 2.5 mile an hour wind, it can knock, you know, something from 96 degrees down to 53, almost in half. So you need to know the technology and cold and hot and how environmental conditions will impact the things that you're looking at. So it's very important. Most electrical rooms are inside. We do have exterior cabinets that are reviewed, and I recently was doing one that was outside, and the sun was beating, so I needed to do it like almost immediately, because once the sun starts hitting those connections, it'll heat them up and it can impact my survey. So just knowing that, also understanding that if you have an infrared camera, you can go do this. Go look at a piece of stainless steel, and all of a sudden with your infrared camera, you're seeing your own reflection in the stainless steel, and you're going, wow. Well, the same thing on these screws. that your heat from your body will reflect, but you want to make sure you're looking at the temperatures. All of a sudden, you know, when you look at these devices, you can go to the left or to the right and you see, oh wow, the heat just went away. Well, we've seen this where guys are reporting faults that there are their own reflections. So keep that in mind. Training, of course, will address a lot of these things for you. You know, he wanted to change this out because it was a his reflection. All right. So another key thing is that you do have to remove the covers. Now, although even with a cover on, you can see indications of problems. There are many times the true problem is not identified till that cover comes off. So again, in commercial, these are things that are done for you. It's not something that you're going to be removing those covers. You do not want to increase your risk in that way. So every one of my jobs requires the client to remove that cover. They provide the electrician to do that. And that's usually a separate contract. I do have electricians that hire me directly, and then I have companies that hire me, and then they also hire the electrician. And sometimes it's their maintenance guy opening and closing the panels. Those are the ones that you usually stand back. When I got a maintenance guy that's opening the equipment, I'm usually pretty far back just in case he blows himself up. Um, you know, I don't want to be blown up, so I want to go home every night. So all right, so this is an example of a loose connection and what you're going to see thermography wise. So keep in mind, loose connection is the resistance that's right at that point. And so the wire will get cooler as it goes away. So when you're looking at a connection and you see it's hot right at that at the screw, then you have an idea that this is, oh, and by the way, look at the right of this, you'll see my reflection in that image. Looks like I'm boiling. But what we're looking at here is just, again, we're seeing a cold wire that goes hot. We know this is a loose connection indication. This is an indication of an overload when you start seeing the heat carrying on the wire out. Now, here's a thing to think about, and you can answer this question to yourself if you know this. This is a 20 amp breaker. What is the maximum load that can go on a 20 amp breaker? All right. By now you've answered this question. The maximum load is an 80% rule, which is established in the electrical code. So 16 amps is the maximum load. This is why I tell you it's very important that we have to do an amperage reading on every circuit. And so you can see right here that amperage reading was taken. We're at 19 amps. This is an easy condition. So I see the problem thermography wise. Now I take a load reading and I've identified that we've got an overload. This is now that goes into my report. The system's got 19.1 amps on a 20 amp circuit. You need to reduce the load and recheck the connection. So it's an easy one. So NFPA, as I said to you, there's criteria tables. NFPA 70B states the following. If you have a 1 to 4 degree temperature difference, it's a possible deficiency. Deficiency 5 to 25 is probably deficiency, and if it's over 25 degrees Fahrenheit, that's a major deficiency. Now, as I said, there's other guidelines. There's mil-spec, there's EPRI, NETA. It all depends on your client. So sometimes the client will tell you the spec that you're going to go according to, which may be what their past or their company, you know, they had a level 3 thermographer who established a criteria table for them. And so what you need to understand is typically major deficiencies sometimes are over 50 degrees. Those many times will have a recommendation. They're going to ask us, a major deficiency requires an immediate shutdown. Okay, that means you have to repair this now. I've had a university that I was doing the survey, and I had a 300-degree fault, and it was on an automatic transfer switch. And I said, this is a major fault. You could hear it buzzing inside. I mean, it was, you didn't physically see it, but the thermal just was glowing. And we got 500 kids. This is back when people were actually in school. Seems like they all miss it now because they're having to sit like you guys and watch web, you know, instructors online. I don't care if you wear your pajamas or not. The reality is most of us want to get out there, and I'm going to tell you, this whole thing impacted my kid's learning. He's 20 years old and he couldn't handle it. You can't get the attention that you need from the teachers. So we really need to get this world back going. Anyways, that's the end of my little political debate there. But deficiencies, they couldn't shut it down because they had 500 kids in there. So you know, but it was the very next morning. We went in there at 5 in the morning and did the transfer, and they were able to repair that connection. So we established the criteria. Once I get major deficiencies, I let the client know, and now I've document that I have advised the management of the conditions, so then they can deal with that. All right, so couple things to keep in mind. Obviously, you're going to be looking at the client's criteria and what they require. You know, my client next week, I've got 5 days of electrical testing in Arizona that I've got to go do, and their criteria, I literally am going to be in jeans and a polo shirt. You know, you can wear a long sleeve. It's going to be hot out there. So, you know, but the electricians are required to be in all that gear. I do have clients that do specify that I'm going to have some safety. So we want to make sure you know a little bit about this. Obviously, there's a lot of, you know, risk that comes down to when you're looking at electrical switch gear testing. And so, you know, the safety is going to be very important.
And so after weeks of
This is, I'm going to skip that, but what I want you to know specifically is has to do with arc flash, and most of this occurs when they do open up the equipment. And you know, so that this temperature, what you need to understand is out of the heat, the light, and the sound, what's going to kill you is the pressure. And so when something explodes, it's hundreds of pounds per square foot to thousands of pounds per square foot of pressure. And this is when the metal and the stuff the debris is gonna explode out during an arc flash. And it's at that point, if you're in front of it, that's what's gonna kill you. And that's why I say you've gotta be trained and know that you have the right gear. And even with some great gear, it's that pressure that sometimes will just go right through that area, but your chances of success are going to be higher. So I need to scare you a little bit. I mean, obviously, I've been doing this for 15 years now, and I'm still around, and I find that it's very safe because I do safe practices. I stand back. I'm nowhere near that stuff when they're opening it. So, and like I said, I assess the people that I'm working with and the team that's opening and closing that equipment. So safety first, last, and always. So, so we talked about NFPA 70A, which is the electrical code. 70B is maintenance and safe practices for electrical systems. Now we've got 70E, which is OSHA. 70E is basically what establishes the safety requirements for like arc flash, that these guys need to be wearing this gear when they open and close that. So the training courses that teach you properly on advanced electrical will go into that. And this is an example. If you have a client, I'll show you the two suits. The one on the left with the big spaceman suit, that is a category 4 suit. And the one on the blue suit with the shield is a category 2. Now the new requirements require you to have a balaclava, which is basically a sock over your face as well. If you have a switch hood, which is the one on the left, then you don't have to wear the balaclava because that one covers down you. But when you look at the shields only go to your neck and they don't cover necessarily the back, and so that's where the balaclava is required. If you're going to be touching anything, the gloves are there. That's why you'll see a lot of the infrared cameras today have come up with larger buttons. This is an example from one of our live training courses. We take guys in the field when we're doing our live courses and actually show them doing that. And so just keep in mind, hard hat and safety glasses, those are often going to be required at different clients on what they need. So you want to see what your job criteria has and make sure that your materials that you wear are appropriate for the industry. Most commonly, a lot of the industrial facilities, they require hard hat, safety glasses, and ear protection. I have one of them that requires me to be in a category 2 suit, which is what you see right there. I don't have to wear the shield. I have to wear the hard hat with that suit and safety glasses. So this particular case, this is an arc flash rating. As I said, there are some of these that will say that you have to have a category 4. And as you read the label, it tells you 18-inch flash protection boundary. So that's where you could be in regular clothing, you know, basically, you know, or a category 2 suit if you're standing at least 18 inches back. There's a category 4. This tells you the flash protection boundary. If you're within 153 inches of that, you have to have a 40 cal suit, and that's the maximum energy at 18 inches. So the good news is that we're not looking at anything really any closer to that. It's the electricians that are going to be getting closer. All right. So obviously, there's a number of other things that are part of it. Typically, anything that's receiving the electricity is what's going to be seen. You're going to see some motors that are done. By the way, just a tip: motors. What you're looking at is what's called trending. Motors are very difficult unless you know a standard criteria for that existing motor, like what's the maximum temperature. It's hard to tell. So what you're doing is you're either doing a weekly, monthly, or quarterly test on every motor, and then you trend it. And it's the main bearing, which is what you're looking at to determine as that temperature goes up, we can predict the failure. So once that motor shuts down, many times those are running, like this one's running, water recirculation or cooling waters. And if that goes down, that can shut down your factory. Many facilities usually have pump A, pump B, so that they have backups in case that happens, but they always make sure that these things are maintained, because this literally can shut down your entire production if that's the case. So just something to keep in mind. And so it's documenting the job. Typically, to give you an idea, is about 2 to 10 minutes per panel, depending on the number of conditions. So a typical thermographer, to give you an idea of what you're looking at, is between 40 and 120 pieces of equipment a day. Now, I'm going to say I have a record. I have a client, I was working for the Navy, and I did 480 pieces of equipment in one day. I don't know anybody else who's done that many, but I will say that they prepped it. They had an entire team, and the engineers were working way ahead of me. They started early, and I had buckets. Buckets are basically small disconnects for motors or fans or so, equipment, and they had everything open when I arrived, and they had a team continuing to keep it open, and then there was a team behind me closing up equipment. So they literally started early and were ready. But on average, you're going to say between 40 and 120 panels a day. I do 2 rates in my business. I do a half day and a full day rate, and the half day rate is basically if they have 30 pieces of equipment or less and they provide me 2 electricians, then I'll give them a half day rate. If they have more than 30, then I'm usually selling them a full day rate. And the cool thing about that is when I sell a full day rate, I get paid for 8 hours of work, even if I work 4. So there's some really good money making opportunities, but I think I have 500 pieces of equipment to inspect this next week, and so I put in 5 days, but I told them to have 2 electricians, which won't be a problem because I do work for this client in other locations, and so that's how I have this job in Arizona, is that, and I was doing sometimes 150 to 180 pieces of equipment a day, so I know that I'm going to get through it in time. And they get billed out. Sometimes what I do is I tell clients, you've got a 5-day job based on your equipment, and if we do finish it in 3, I'll give you a half credit on any unused days. So there's different ways to skin a cat so that you're covered if you are blocking yourself off for that time. The pay will depend on your experience and the scope of the jobs. As I said, I'm 1,600 a day as my minimum. I do get clients that I'm charging $2,500 a day for. I do have a couple of clients I do that for because we have some travel involved. Sometimes it's more. I have clients that I charge a fixed rate. Usually my out of state is around $2,000 a day, and then I charge expenses all on top of that. And so I have a couple of clients doing that. Also, there's areas of the country that will impact this. So there's guys that are just, because the competition, they're trying to get 800 a day. But I'm going to tell you, there's a difference between this work and the work you do as an inspection. So you're booking your work out for home inspections, within a week, and you don't know what you're doing a month from now. This work is booked months in advance. And so it's really good because if you expand your business commercially, you're able to set up time and then you can add or subtract from your home inspection company, like adding more inspectors to do that, to keep that going. You know, you're booked out. So I have other inspectors that work for me, and we've been cranking busy up until this week. It started to slow down, which is normal. This time of year, we start slowing down, going from October down to, the end of the year, right after the holidays. We're usually seeing a decline, and then January we'll see a rise again. And I get a lot of this electrical testing that's done at this time. So it really works out for me because I fill up my other guys with home inspections, and I'll go out and do this, which pays me really good. But again, being able to know that your nut is covered by getting, even if it's $1,000 a day, heck, we can charge less for home inspections if we were guaranteed we had, continuing that work. But we don't know. Like COVID hits, and like most guys, that last March through, May, guys were twiddling their thumbs literally between May 15th March 15th and May 15th. For a couple of months, I was doing like 3 or 4 inspections a week. I had sellers that wouldn't even let me in the house. So what do? It's nice having these ancillary services that you can supplement your income with. So just keep in mind, standards require that the systems be loaded to 40%. So you need everything to be on. You're not going to show up at 6 a.m. if they don't get into the office at till 8, or they don't start production till 8. You're going to be getting there and working during normal working hours. Um, the most painful part of this entire survey for many guys is the report writing. I'm going to tell you, this is where electricians just don't get it. They want to go buy an infrared camera to capture this work, but these guys just don't like sitting at a computer. They want to pull rope. They don't want to sit there and go back and sit on a computer. And on the average, a guy who doesn't do thermography, he's spending, for every day in the field, he's spending a day behind a computer. And I'm going to tell you, this is where we win as inspectors, is we're used to writing reports. We have to do this as part of our job. So this is the same thing. I typically spend about an eighth to a fourth of my day. So for every day on site, I'm spending maybe an eighth of my day, doing the report writing. So it takes me an hour for every 8 hours. So I got a 5 day. I'm going to probably spend, honestly, between 2 and 4 hours completing up my final report at the end of that. And so just keep in mind. All right, so here's the thing. Who are the clients? Every business and facility that utilizes electric power. So, your market. We're tied specifically to jobs, home inspections. If the houses aren't selling, they don't need a home inspection. But every business that's operating needs it. And recently, a couple months ago, I had to do a university. I did a college of law in San Diego. So Western College of Law. There was no students. There was nobody there. And I said, what do you do? They said, we have to do it. It's insurance requires it. Okay. So I had 2 days on this facility doing all their electrical, and they just had to turn on all the lights and run all the ACs and everything. And we did the job, and we found problems, but they didn't have the load they would if the students were there. So things like, these are kind of some of my jobs and stuff that I see. And I can give you guys some examples. I get all kinds of clients. These are just this year on the bottom right. This is a Metrolink train system, and we're looking at the overhead catenary system. So I'll show you some examples. So this one is just this job was over about I think I did about $15,000 on this job for probably about 7 days of work. But I'm going to show you an example of what I see. This is brand new. I don't know how fast this is coming through, but this is a brand new electrical install, and the requirement was they had to do testing of this. And what you can see here is that when the train passes, I was looking at the feeder taps, and in this particular case, I was getting an arc and a feeder tap that was overheating. So I'm showing you the pictures, and hopefully it's coming through on your screen. But you can see where that, And literally, this was a requirement for them to get paid on this job. They put in new wire, and I had to check all the feeder taps to make sure that the wiring was done right and there was no bad connections. And ultimately, this is over 266 degrees that was occurring at this. And then I had some arcs. This is a visual picture. Actually, we were able to get the arc that was occurring as that pantograph. That is called a pantograph, just so you know, as it passed through. So that's an example um, of that. This company on the bottom left, I had to block out the logo, so I had to keep it as, I can't disclose this, who the client is, so I blocked it off so you guys can't tell. Nobody on this webinar can tell who this client is. Anyways, this is a job that I did recently, and I got to move this over here. This is a big warehouse, and I was looking at the freezers, and I, of course, blocked out all the criteria so you guys couldn't tell. This is an example showing the data log. I show the faults that were found on this, and this is a brand new switchgear just installed. Again, they required to have an infrared scan of that prior to going. So I'm hoping that these transfer. I'm assuming everything, I've got it on the main screen, so hopefully these come over to you guys. And unfortunately, I don't know if it's not coming over for you. But anyways, this is just an example of what I'm looking for. We want to see phase balance. We're looking at the connections. These are the types of jobs that we're doing. From the top left is like a lift station. This is a commercial building, apartments that we're looking at. This is a ship. This is a military ship. This is the Bob Hope class. This is about the size of 3 football fields. And so I usually spend sometimes 2 to 5 days on these ships. They're usually while they're in port, but some guys that do these ships, they go out to sea sometimes, which is pretty cool. They feed you good. By the way, these are civilian run. This particular fleet is civilian run. They'll have a few military personnel, but mostly civilian, but they have a galley down there that, I mean, these guys are serving like steak on there and stuff. And so I'll kind of show you, like, this is kind of the equipment list, and then I'll kind of get down to where the faults are. And as we find, temperature criteria, you can see my reports will look sometimes different, and that's because the client has a request for a certain type of report that we see, and so that's where the difference will occur on that. And so, the idea behind this is that I go out on site, I document conditions that are seen, whether it's overhead, switchgear, in a pump station, at a industrial facility, or for a residential condominium complex. There's all kinds of work. I mean, over the years, I've made millions of dollars in thermal imaging. I've never looked back. The investment is nothing. Typical guy getting in this is going to take him a little bit of time on recouping. I'm going to basically want to make sure we have some time for some questions. So I'm going to kind of, finish out on presentation aspect. But why are home inspectors ideal candidates for electrical surveys is because most all home inspectors perform some type of commercial inspections. And so you're already offering this, and basically to tell your client another $1,000 or $2,000 or whatever to have the electrical tested. If you're working on a strip center, keep in mind, if you guys haven't heard the term of triple net, that means that the tenant's responsible for maintenance. Believe me, I can show you commercial roofs that I've done where tenants were responsible for the roof. I went back 2 years later, and I found water problems in the roof, and the tenant painted the roof. They put a coating on it, but the problem was still there. It was a Band-Aid that didn't fix the problem, and here we have a lot of plywood deck roofs, so they rot out. So electrical is the same, that the owner's responsible for the building, but the tenant's responsible for the maintenance of it. And they often are doing what's called a TI, a tenant improvement. They add electrical. The owners can require them to get those infrared scans, or maybe the owner just does the scan and protects their asset. And if problems are found, they make the tenant do the repairs. So those are things to keep in mind. So for you guys to add this to your commercial business is you know, an opportunity. So why not add these additional services and make some more money, right? All right, so I'm going to leave some times for some questions. Brenda or Miranda, whoever has some questions, I'm going to let you guys come back. And if you are interested in learning more, you can go to our website, electricir.com. You can see some more examples. There's a webinar that you can do if you go to unitedinfrared.com/join, where I explain a little bit more detail about the thermal business as a commercial aspect, kind of as another finger to your business and your investment portfolio and how you go forward. It's so easy. Look at this dog. I trained this dog to take pictures. You could do it. And so if there's any specials on equipment, you guys can just use your cell phone and capture that QR code. But I'm going to open it up to some questions. And Brenda, do you have any that have come across, or are you going to bring them on live, or how would you like to go about that?
I do have some questions for you. So the first one that I would ask is, what would be a good starting camera for the home inspector?
So there, when it comes to an infrared camera for just home inspections, all right, the reality is, and I tell guys this all the time, there is no customers that's ever going to call you for your home inspection and say, well, what kind of infrared camera do you have? What kind of training do you have? It's rare if they're going to ever ask you the training, and they're never going to ask you what kind of infrared camera you have. If you guys do sewer inspections or radon, they're not going to ask you what manufacturer radon you have. So the reality is, the answer to that question is any infrared camera will do when it comes to home inspection. When it comes to commercial inspections, you're going to need to start looking at the price point. And so I'm going to tell you, you're going to be spending minimum $5,000 on an infrared camera if you're interested in doing commercial. And that means you've not only made that, you've made the decision that you're going to get level 1, level 2 certification. So this is an investment. The minimum you guys are going to be looking at is at least a $10,000 investment. But I've told you clearly, guys, there's a difference between the word investment and expense. I invested $20,000 and I've made millions. So hopefully that answers your question there. What else you got?
Okay, and on that point, did FLIR develop a reliable program for Apple computers for infrared reports? For years, they have not had any programs. They did have one, but they had problems with it.
So to answer your question is that, as you know, with an Apple, you can run an emulator, and the product that person is actually questioning on is on regarding a FLIR reporter software or FLIR tools. There is some new software that came out that is Apple friendly. And so the answer is yes. I'm going to be honest with you. I have not myself. I currently use FLIR Tools Plus for my reporting, and I use a PC based computer. But computers have gotten so cheap now, like literally in the hundreds of dollars, but a decent like PC you can get for 500 bucks. I know you're an Apple fan, but it's okay to have something specific for reporting only and use your Apple for everything else. But the answer is the new softwares, report studios that FLIR has are all Apple friendly. And if you use an emulator, you can install those and run where you turn your Mac into a PC. So if you do that, then it'll run flawlessly. I have plenty of guys doing this in our system that are Apple fans and won't touch a PC for the life of them, but they'll make their Apple into a PC. Go ahead, next question.
Okay, and the next question would be, what would you price a commercial IR inspection?
So I discussed that in my presentation, and that my fee structure when I go out on electrical testing is my minimum is $15.95 a day. So for home inspectors, there's a lot of guys that say, hey, what's a good number? And that's usually in that $100 an hour range. You can see at $1,600, I'm making $200 an hour. And so it's pretty good. And the fact that it's consistent where we get this over and over like every year, that's the beauty of this, is that I've got about $75,000 of annual commitments every year pretty much for the rest of my life that are just infrared. And then all the other work I do every year is just jobs that come in. but I get some that are already committed every year for that amount. So I tell you that, it's going to be based on a little research in your area. You may find that you're heavily loaded or not. Guys, Walmart was never afraid of Target or the reverse. They will open their business up across the street. You can see it. Gas stations are across the street from each other. They compete all the time. Don't be afraid of other guys doing it in the business, and don't be afraid to charge what you deserve. Next question.
Okay, and looking at the time, we've got about 4 minutes, so this may be the last question. How do you start to get the word out to your future customers that you are a thermographer? I'm sorry, I was trying to say it, reading it. Okay.
Okay. Let me. Sorry for that. Go ahead. How do I get the word out? So first of all, the word out is on uh, simply looking at your current client database. So if you have commercial clients that you've done inspections for in the past, then you will basically be able to let them know that you have this new service. For me, I built a separate website specific to thermal imaging so that it's not just through my home inspection platform, but that I can market to that directly. And then now going forward, when you do offer services for clients, is being able to offer that service. You want to make sure you have the right equipment and training though to go with that. And hopefully that answers your question. What else you got? You got anything else? And we got
All
time
right.
for another one or two?
I have looked here at all the questions, and many of them you answered during the presentation, so I was trying not to re-ask. Here's one. Also, what can you do with a level 2 certification other than just electrical?
So level two, so we tell guys that pretty much if you want to do any thermography, you're going to need a level one minimum. A level two, the reason why we tell you that you need a level two to do thermography is because that's where quantitative analysis comes in. And because that your competition is likely going to be a level two who's doing electrical, that's why you need it. So the answer is you could do anything, any service with thermography. You've learned quantitative analysis, you've learned the physics of thermography, you can do any job. I'm going to tell you guys, I had a zoo in Idaho that flew me out there to look at a giraffe. I got pictures. If you look at my Instagram account, there are pictures with me with the rarest mammal in the world, which is a northern white rhino. There are only two left in the world, and I was working with the San Diego Wild Animal Park and identifying abscesses in the rhino. And I've been out on a ghost hunt. So the opportunities are endless with thermography. And so all I say is just, you guys, it's your imagination. And when a client calls you, that you take the job. So my contact information is on the screen. You can drop me a note, an email, and I'm happy to, help you guys if there was some more questions that came up. But with that said, I'm assuming we need some time to transfer over. I think we have some, vendor hall that if guys have questions, I'll be on today. My team members will be on tomorrow because I'm traveling. But is that the last question, Brenda?
Yes, sir. That's the last
All
question.
right. So
Thank
let's
you.
close out with a little Eddie Grant, and you guys can bust a move. So let's see. Did that work? Come on. Let's get it. Yes. Can you hear it? Give me a thumbs up, Brenda. Can you hear it?
I can hear it. Thank you
All
so
right.
much.
All right, guys. Well, thanks for taking the time today, and we appreciate you spending your morning with us. And I hope you enjoyed it and I can be impactful for your business.